We have a indefinite integral here. It's the indefinite integral of 2 over e to the negative x plus 1 dx. Let me select the little crayon here. And basically, I don't really know how to tell you to start doing this. I guess you could start thinking about setting u equal to something, but the best suggestion I can tell you is whenever I see an e to the negative x, I mean, it doesn't always work, but whenever I see an e to the negative x in something, and especially if it's in the denominator, but really anywhere in the integrand, the function that you're integrating, I think, well, maybe I might want to put that out of negative exponential notation and just kind of look at it. And to be really honest, just another tip is, I mean, just personally, I like to do that when I have e to the negative x. Almost always, I like to write it as 1 over e to the x, just because it makes it more clear to me what the expression actually is. That's just me. The negative exponent sometimes doesn't always say denominator to me. But anyway, that's not really has to do with this. But anyway, when we write it like this, it's obvious we have a compound fraction. So my suggestion would be to make this into get a common denominator of this denominator here, and then rewrite as a simple fraction. So when I do that, the common denominator of this lower portion of the fraction here, the denominator we're just trying to avoid saying denominator a lot, is e to the x. So I just need to multiply this 1 by e to the x, and I can rewrite this denominator as 1 plus e to the x over e to the x dx. And this might even be a good, scratch work off to the side. So now I can pull this this fraction out to the side and multiply by the reciprocal. Pull it out of the denominator and multiply by its reciprocals. So I would end up getting 2 times e to the x over 1 plus e to the x. And now I would hope anyway that it's readily apparent what to set u equal to. In fact, you could even just use your standard rules of set u equal to what's in the denominator. You can factor out this 2 in the beginning. That might help people. For some reason, I used to do that a lot when I first started doing integration. I was really big on it, and then over the years, I've just more or less left it in, and I think it's because I tend to forget about it if I take it out. So that's just a personal thing. So I probably encourage you to take it out. A lot of people do. So anyway, that aside, I'm going to say u equals 1 plus e to the x, and then du equals e to the x, because the derivative of 1 is 0. The derivative of e to the x is e to the x, and then of course dx. Well, I have e to the x dx in the numerator here. So circle that. So I'm going to just substitute du in for that. And of course make u is 1 plus e to the x. So I'm going to have 2 and then over u and then du. And now we have 2 over u, that's u to the negative 1. So we know that that's 2 times the natural log of the absolute value of u plus c. And then I'm going to sub back in for u, which is 1 plus e to the x. So I'm going to get 2 times the natural log of the absolute value of 1 plus e to the x plus c. And two things you could do here. You can drop the absolute value symbols at this point, because 1 plus e to the x, well, e to the x, is basically, I don't know if this is really worth the time it takes, but anyway, to draw this little graph. But anyway, I'm going to do it. The basic, e to the x function looks something. See if I can pull it off. Ooh, well, it doesn't look bad. Anyway, it doesn't look quite like that. It has more of a shape like that. But anyway, my point is it's never negative. So 1 plus a number that's never negative is a positive number. So therefore, the absolute value symbols aren't necessary. Another reason why the absolute value symbols wouldn't be necessary, even if this value could be negative, is this 2 out in front. Remember, you can pull that up to as the exponent of the argument of the logarithm, so you could actually rewrite this as the natural log of 1 plus e to the x squared plus c, and that actually takes care. I don't really encourage you to take absolute value signs off. I really don't even know why I just showed you that. Although you'll see solutions manuals do that. That's actually always a good argument for showing you things like that. And I don't know. To me, absolute value signs look weird. And if I don't need them, I don't need them. So anyway, sorry. Talk to you later.